It's Alan with Carnage and Mayhem. I'm about to start a new drone build, and I was looking at the different frames that I could possibly use. And I happened to be in Jacksonville, went to RC and Go, a little hobby shop there, and met this guy named Cecil. He says he's with Drone Kings FPV, and he started talking to me about how they are designing a new frame and how they're mounting the battery. And they come up with something that they call relative pitch angle. So when we fly quadcopters, typically, we've got the battery mounted flat, but your quadcopter's in the air at 25, 30 degrees, whatever you're flying at, so that battery is at that angle. They pitch their battery so it's level relative to the ground while the quad is in flight. They call this balance core theory. Anyway, they currently don't have any frames for sale. They've got a website up, FPV, or Drone Kings FPV, and they've got a couple of their quads there. They look cool, but you can't get them. So I started looking for a frame that could possibly allow me to do that, and I found this one from Gep RC. This is the Mark III, I believe. The top of it is at a 25-degree angle because they intended you to mount a GoPro camera or some action camera on the top of that, with the battery being slung underneath like a typical race quad. However, I'm going to modify this one so that I can put the battery on the top so it's at that 25-degree angle. So I typically set my cameras at 25 degrees. So we're going to have a quad with the battery at this relative pitch angle like Cecil was mentioning, and we're going to see if it flies any better than a standard one. So let's get to it. I'm using a 4-in-1 ESC, a flight controller that I like. I think this is a CL Racing one. I designed and printed a receiver mount, so I'm using a Spectrum receiver, so this can just slide in there, and I've integrated some mounts for antenna so I can have the antenna tubes just kind of mounted in there. The one thing that I'm kind of liking about this frame so far is there is a ton of room inside of this thing. So it makes it relatively easy to slide the stack in and pull it out. So far, this frame is pretty cool in that regard. The other thing that's really neat about the frame is the fact that there's 2 bolts on the bottom, and if I remove these 2 bolts, it'll swing on a hinge here so I can open up the entire top. So that's going to be pretty nice too. For this build, I'm using a Spectrum receiver. So on this flight controller, I'm going to use ground and 5 volts for the receiver power, and I'm going to use the satellite pad for the signal. I'm also, since I've got telemetry on this receiver, I'm going to pick up positive and ground from these 2 ESC pads. So first thing I'm going to do is tin these pads. That's that. So now I'm going to solder the wires for the camera connection, and I'm going to use cam minus, cam plus, and cam signal pads for this. So I've got 3 wires. My yellow wire is going to be signal, red is cam plus, and black is cam minus. So let's tin these pads. these wires in. I'm going to turn this slightly so I can deal with it a little bit better. My video transmitter, the connector, has 5 wires, but I don't need them all. So we've got a voltage out, a ground out, signal in, and there's ground in and power in. So I'm going to pull these 2 wires out just so they're not in my way. I'm going to do that by popping up the lock on each one of these. So now I can remove those wires and just have the 3 wires that I really want. For the VTX connector, I'm going to use pads VTX signal, VTX plus, and VTX minus. So let's again tin these pads. Let's solder the wires in. I'm going to turn this so it's easier for me to get to. They're already pre-tinned, but it never hurts to get solder on there. I'll fast forward through soldering the wires onto the ESC pads, but you can notice that I'm angling 3 of the wires to each corner of the quad. I noticed that one of my soldering jobs here is a little bit wonky, so I'll take a little bit of time to reheat this pad, resolder it, and get it correctly into position. Now I've got the stack done. I'm going to go ahead and get the frame out, and let's start connecting all this stuff together. Now it's time to connect the camera connector and the VTX connector. A little bit small and tight in there, so I'm going to use tweezers to push that camera connector in place. I like using these race wire printed circuit boards because I think it makes it a little bit cleaner build. Don't have to worry about wires all over the place. So I'm going to go ahead and just pin these pads, and I've already cut my motor wires to length, so I'll just go ahead and connect these in line on each pad on the printed circuit board. I'm only going to show soldering 2 of the arms here, because it's pretty much the same process all over. So I tin the pads, grab the wires, and solder them on. Soldering the other end of the race wire printed circuit board is pretty much the same. You just take the ESC wires, fit them to length, and then cut them. And then I strip the end of the wire, tin the wire, and then I'll solder them on. What I really like about the race wire, like I said, is it just makes a really clean wiring layout. I don't have to worry about all kinds of tie straps and tape and stuff. I'm only going to show soldering one of the ESC ends to the race wire. It's the same process all over. I just want to kind of show how I'm measuring the lengths and soldering the wires. Pretty happy with it. It came out fairly compact and looks pretty good. I really like how much space there is inside the frame. I think everything worked out pretty well. So the next step is we got to smoke check it. We'll just double check, make sure that we don't have any shorts, and then we'll hook it up to the computer and get all the rotation set up and then see if we can fly this thing.